Now, in this video, we're going to take up one more problem on the projections of lines. The problem reads as, draw the projections of the line capital AB 100 mm long, inclined at 45 degrees to VP and 30 degrees to HP. One end of the line is 20 mm above HP and in VP. Determine the apparent lengths and inclinations. So the problem reads, a line capital AB 100 mm long. So that means, since it's the line capital AB, that means he has given the true length of the line. And then he has given the inclination, that is 45 degrees to VP, that is phi is given to be 45 degrees, and 30 degrees to HP, that is theta is given, that is 30 degrees to HP. One end of the line is 20 mm above HP and in VP. Now we'll try to see this, the three-dimensional sketch. So here he says, a line capital AB 100 mm long is inclined at 45 degrees to VP. Since the inclination is given with respect to VP, so you have to see in HP. That means it will be the top view. And 30 degrees to HP. So that means it will be in VP. One end of the line is 20 mm above HP and in VP. So above HP distance where you can see, I can see the distance above HP in VP. So that means when you are looking, where you are going to see the image in VP. If you want to see the image in VP, from where should I look? I should look from the front view. So when you look from the front view, you can see the point A is above HP by 20 mm. And in vertical plane can be seen in HP. So when you look from the top view, the point is on XY line. It is in VP. So above HP and in VP. So he says line capital AB 100 mm long. So this is the point A when you look from the top view, and when you look from the front view, this is the point A dash. And he says inclined at 45 degrees to VP. So the true length of the line. So what is the true length? Line is parallel to HP, where you can see that it will be in VP. Now, when you look from the front view, it is 30 degrees to HP. So therefore, when with A dash, a center, you draw a line which is inclined at 30 degrees to HP, where you can see the distance, where you can see the angle, you can see the angle in VP. So that is the reason why you are able to get a line of 100 mm long, inclined at 30 degrees to HP. So that will be in vertical plane. And 100 mm long is also inclined at 45 degrees to VP, where you can see VP can be seen in HP. So the point is in VP. Since the point is in VP, when you look from the top view, it will be on HP. So from XY line, you draw a line which is inclined at 45 degrees to VP. But where exactly that point will going to be? So that point is on 20 mm above HP. You can see that point here. Why? Because we have to take 20 mm above HP. That is because above HP distance is seen in VP. So you are getting the scene in VP. Okay. And in vertical plane. So this point is in vertical plane. So when you look from the front view, I can see the distance above HP of 20 mm. From this point, you are drawing a line inclined at 45 degrees to VP in the three-dimensional space. That is the reason why you have capital A and capital B2. So now you know that when you look from the front view, the line is parallel to HP. Where you can see that line parallel to HP, you can see the line parallel to HP from the front view. And now when you look from the top view, that image will going to fall on the vertical plane. So you know this is a 100 mm long inclined at 45 degrees to VP. So this is how you will be able to write the first position of your drawing. And here, once you get the point B1 dash here, and also once you get the point B2. So these are called the locus of B in the front view, and these are called the locus of B in the top view. Why it is called as the locus? because in this position we will be able to get the front view of the point B dash, and in this line you will going to get the top view point of B. So since it is capital AB, since the line is parallel to HP, so you can see the line is parallel to HP, therefore you can see the true length in VP. So therefore you can see, the line is parallel to HP, therefore you can see the true length in HP. So you can see that capital A and capital B in the top view. And when you look from the top view, point A is in VP and point B1 dash is also on VP. Therefore the line is parallel to VP. Since the line is parallel to VP, you can see the true length in VP. So that is the reason why you have capital A and capital B. Why it is parallel to VP? Because the point A is already in VP. So obviously, since it is the true length, the point B1 dash should also be on VP. Then only the line will going to be parallel. Why? Because it says that line capital AB of 100 mm long. Since it is the line capital AB, so you always remember the capital AB means the true length of the line. True length means the actual length of the line. So this is the first position. Now I want to write the orthographic view of this. That means I have to rotate this HP down by 90 degrees. When you want to rotate this HP down by 90 degrees, then what happens? The top view of the image will going to come down, whereas the front view of the image will be there itself. Now you can see, you have the XY line and we have VP and HP. The point A is above HP by 20 mm. So you are going to get A dash. The point A is on VP. If it is in front of VP, it will come below XY line. Since it is in VP, so it will be on XY line in the top view. So we have the point A and capital A. So from this point, you measure an angle of 30 degree and draw a inclined line of 100 mm long, so that you are going to get the point B. So since it is the true length, so you are going to get B1 dash, because I am considering this as the first line. So B1 dash, and you draw a locus, and since it is the true length, so you write capital B, and this is the locus of B, where the front view point of the line B will go to line. Similarly, with small a as center, that is in the top view, you measure an angle of 45 degrees and draw a inclined line, and by taking the compass, cut an arc of 100 mm length, because the true length is same both in the vertical plane and as well as in the horizontal plane. Since this is B1 dash, so this will going to become B2, and you write capital A and capital B, and then you write this is the locus of B. Locus of B means the top view of the point B will going to lie on this line. Now as we know that it is the true length, so what I need to do? So since it is the true length in the vertical plane, means it should be parallel to VP. Now we have the front view, that is A dash B1 dash. To this I need to write the top view. How to write the top view? So I have to look from the top view. When you look from the top view, why? Because you have the front view. The front view is A dash B1 dash. What is the top view of this A dash B1 dash? The top view of this A dash B1 dash is A B1. But when you look from the top view, the point A is on VP. But we don't have the top view of the point B1 dash. Where you are going to get the top view of the point B1 dash? The top view of the point B1 dash should also lie on the vertical plane. Why? Because point A is in VP, so B1 should also be on VP. Then only the line will going to be parallel to VP. The top view of the point B1 should also be on VP. A is on VP, B1 is on VP, therefore the line is parallel to VP. So since B1 dash was there, I didn't get the B1, so I am writing the top view for that. So A is on VP, point B1 is also in VP. Now the line is parallel to VP in the top view. So once you get this point, so this is how we will be able to write the top view for the front view true length line. And this is 100, but this will not be 100. AB1 will not be 100. AB1 will be less than 100. Similarly, when you look from the front view, I can see the point A is above HP by 20 mm. What is the front view of the point AB2? The front view of the point AB2 is A dash, B2 dash. But do you have the front view of the point? No. We have only the top view of the true length line. The top view of the true length line is AB2. But to write the front view of the point, so A dash is there, but we don't get B2 dash because B2 dash is not there in the given problem. Since in the problem he has given that capital AB is the true length, therefore this will going to be capital A and this will going to be capital B2. Why? By a point A is above HP by 20, the point B2 is also above HP by 20, therefore the line is parallel to HP. So, if the line is parallel to HP, then I will going to find the true length in HP. So, you have capital A and capital B. So, since I don't get the front view now, so I need to write the front view. So, by looking from the front view, A dash is above HP by 20, B2 dash should also be above HP by 20. Then only the line will going to be parallel to HP. So, therefore, when you look from the front view, you project a line from capital B2 so that it will going to lies on the vertical plane which is at a distance of 20 mm above HP. Why? Because A dash is above HP by 20, so B2 dash also should be above HP by 20. Then only the line will going to become parallel to HP. So now A dash B2 dash is the line which is parallel to HP. Since A dash B2 dash is parallel to XY line in the front view, obviously the corresponding top view AB2 will going to be in true length. So you have the true length in the top view. How do I know that this is the true length? Because he has given the problem. Now, I need to write the orthographic view. How to write that? In the initial stage, we have the front view of the true length and we have the top view of the true length. Now what I need to do? I need to write the top view for the front view true length and I need to write the front view for the top view true length. Now first what I will do? I will consider the front view, that is A dash B1 dash. So when you write the top view of A is on VP because this is given in the problem. So since it's the true length in the vertical plane means what? It should be parallel to VP. So A is in VP, B1 should also be in VP, then only the line will be parallel to VP. So therefore, from the projections of lines rules, what we said, when the line is inclined to HP and parallel to VP, then the true length is in VP. That means if the top view line is parallel to XY, its corresponding front view will going to be in the true length. So here A dash is there, B1 dash is there and A is there in the problem. But we don't have the B1 dash. So I want to get the top view point of B1 dash. How to get the top view point of B1 dash? A is on VP, so B1 should also be in VP. Then only that line will be parallel to XY. That is, small AB1 is the top view point for the front view true length, which is A dash B1 dash. So then from B1 dash, you draw a vertical projector tilt to the XY line and you mark that point as B1. So AB1 is parallel to XY in the top view, therefore you can see the true length in the front view. Similarly, now we have the top view point. AB2 is the top view true length. If the AB2 is the top view true length, that means that in the front view that line should be parallel to XY. What is the front view of AB2? The front view of AB2 should be A dash and B2 dash. A dash is above HP by 20 mm, therefore B2 dash should also be above HP by 20 mm. Then only the line will going to be parallel to XY. So draw a vertical projector from B2 such that it will going to lie on the line of A dash, which is above HP by 20 mm. So from B2 you draw a vertical projector tilt to the 40 mm and 20 mm above XY line. So that you are going to mark this point as A dash and B2 dash. Now you know the top view point, no, you know the top view, this is the true length. Therefore, its corresponding front view should be parallel to xy. AB2 is the true length of the line in the top view. Its corresponding front view should be A dash B2 dash. Since A dash B2 dash, now it will going to become the parallel to xy in the front view. Therefore, the corresponding top view point AB2 is in true length. So that is the reason why you have denoted that by capital A and capital B. Now what should I do now? After that, now I want to get the top view. So, if you want to get the top view, initially where exactly the point now? It is on AB1. But the top view point of B1 is not on XY line. Instead, it is in front of XY line by this distance. So that is the reason why we have the locus of B in the top view at this point. That means what does it mean? I want to rotate the point B1 with respect to A such that it will going to lie on the locus of B in the top view. How to do that? With A dash as center, take the radius of A dash B1 dash in space, you rotate it such that the image what was here, that is B1 dash to B1 was here, which is being rotated such that it will going to come and touch us with the locus of B in the top view. So now this line join AB, this is the top view line, that is capital A and capital B. This is the one what we are talking about. So now you got the top view point which is on the locus of B and join AB. Why you have to join AB? Because capital A and B is being joined here. So when you look from the top view, that image which was AB1 has been rotated such that the B1 will going to come and touches the locus of B in the top view at this point. And you mark that point as AB. So you join A and B with a dot line. And now the same thing which we can do here. So because due to the presence of the locus of B in front of VP by some distance, but AB1 will not be on the XY line. But A will be on XY line because A is already given in the problem that it is lying on VP. Because due to the true inclination with respect to VP is this much, that is 45 degree, obviously the top view point of the B is not on the vertical plane, but it will be in front of vertical plane by this distance, such that the distance between distance of the point AB1 will have the same distance as AB. So that can be possible only by drawing an arc. With A center, taking the radius of AB1 by using the compass, you rotate it such that it will going to come and cut the locus of B in the top view. And you mark this point as small b and then join A and B with a dark line. So once you do that, you have got the top view. So you mark that point, which is, you mark the inclination, which is beta. So that is the apparent inclination with respect to VP as beta. Similarly, now we will going to take up how to do the front view rotation. How to do that? Now, when you take the front view into the consideration, you know that this is the front view which has got A dash and B2 dash. So which is that point, capital A and B2. With A as center, taking the radius of A dash B2, capital A B2, you are rotating such that it will going to come and touches the locus of B in the front view at this particular point. So how I am rotating? With A as center, taking the radius of AB2, when you are rotating it in space, because capital E is above HP by 20, capital B2 is also above HP by 20. So, but because due to the presence of the true length in the front view as at 30 degrees, so this will going to be the locus of B in the front view. So you are rotating that in space. When you are rotating this in front view in the space, what happens or image on the vertical plane? You can see the image A dash B2 dash is also being rotated. You can see that. So the image is also being rotated till where it will going to be rotated, till to the locus of B in the front view. So now the B dash, mark that point as B dash, join A dash B dash with a dark line, and you say that is the inclination made by the line with respect to apparent inclination made by the line with respect to HP, which is A dash B dash. So this is how you will be able to mark that point and mark that angle as alpha. So this is how you will be able to solve the problem. So when you join B dash and B, both will going to lie on the same line. So this is the inference that if B and B dash lies on the same line, then whatever the problem you have done is right. Otherwise, there is something wrong in it. So how to show that in an orthographic view? Now you can come to this. Now, with A dash as center, taking the radius of A dash B2 dash. Why I have to take the radius of A dash B2 dash? Because since it is the true length in the horizontal plane, so it is parallel to HP. You know that the true length in the horizontal plane is this. So when you look from the front view, A dash is above HP by 20 and B2 dash is also above HP by 20. Now the line is parallel to HP. Since the line is parallel to HP, so you are getting the true length here. Now we have already got this point. Now what I want to get the B dash point. So how to do that? So because the true length of the line is inclined at 30 degrees to HP, so what happens to the, which is 100 mm long, so what happens to the locus of B in the front view? The locus of B in the front view is not above HP by 20, but it is above HP by more than 20 mm. I don't know what is this distance, but I know this point and we have the locus. I know that the front view point of the B dash should lie on this locus. So with A dash as center, taking the radius of A dash B2 dash, by using the compass, you draw an arc such that it will going to come and cuts the locus of B in the front view. So you mark that point as B dash, then join A dash B dash with a dark line and mark that angle as alpha. So this is how you will be able to solve the problem, and when you join between B dash and B, both will going to lie on the same line. This is to check that your problem is right or wrong. If the problem is wrong, then both B and B dash will not going to lie on the same line. And by using the scale, you measure A dash B1 dash, which is you measure A dash B dash, which is 70.71, and you measure AB, which is 86.60 mm. Then by using the protractor, you measure an angle of alpha, which is 45.00, and for beta it will be 54.74. Since you are doing it in CAD, so the accuracy of the drawing will going to be up to the second decimal point. So you measure 70.71 mm, you must get exactly to the second decimal point, then only your problem is right. Otherwise, you have done something wrong. So this is how you will be able to analyze the problem and solve it. Now, how do I know that my problem is right? How to identify that? You can see the point A is above HP by 20 mm and it is on VP. The true length of the line is 80 mm, which is inclined at 30 degrees to HP, and the true length of the line capital AB is 100 mm long, is inclined at 45 degrees to VP. You know that this is the front view. You have in the front view this line is in true length. That means that corresponding top view is parallel to XY. What is the top view point of A dash B1 dash? The top view point of A dash B1 dash is the top view is AB1. Now the line is parallel to XY, therefore this is in true length. Similarly, you know that the true length in HP, both the true length is same in front view and top view. So this line will going to be 100 mm inclined at 45 degrees to VP. What is the front view of this line AB2? The front view point of this AB2 will be A dash B2 dash. So if the front view line is parallel to XY, you can see that A dash B2 dash is parallel to XY. Therefore, you are getting the true length in HP or true length in the top view. Then, after that, what you have done? with A center, taking the radius of AB1, you draw an arc such that it will going to cut the locus of B in the top view. So you have that B and mark B and join AB with a dark line. Similarly, with A dash as center, taking the radius of A dash B2 dash, you draw an arc such that it will going to cut the locus of B in the front view. And you mark that point as B dash and then join A dash B dash with a dark line. And when you join B dash and B, both will going to lie on the same line. You know this is the top view. Why? Because the front view line is inclined. You know that this is the front view because that the top view line is inclined. So this is how you will be able to analyze the drawing and solve it. So this is the one which is required, and the answers are given, answers are measured or determined by using the software itself, and you have to be tabulated this. So this is how you will be able to solve the drawing. This is how you will be able to analyze the drawing in 3 dimension and as well as in the orthographic view. Thank you.